Hello students, today we are going to learn through this session electric potential and capacitance of application based numerical problems. Various topics we will achieve through this session. Let us see one by one in detail, children. Yes, in electric potential and capacitance, first problem, the charges 2 mu c and minus 2 mu c are placed at the points A and B 6 centimeter apart. Questions are, identify an equipotential surface of the system and what is the direction of the electric field at every point on this surface. See, the first question to arrive at is identify an equipotential surface of the system. So, you have to take for that both, that is axial and the equatorial. To know about that, you must know what is dipole moment. First, we will write all the given. The first one, they have given dipole charge strength. Okay. The charge which they have given 2 mu c. And the length which is 6 centimeter, we have converted into 0.06 meter. To know about the dipole moment, the formula, you have to check the previous sessions. And you may get the formula which is P, which is equal to Q into D. The dipole moment is Q, that is nothing but the charge of either minus Q or plus Q, the charge opposite direction or the same direction into the distance we have to take it, right? That is dipole moment. After we have taken the 2 into that 0.06 meter, you will get 0.12 into 10 to the power of minus 6 coulomb meter, right? This is for the dipole moment. After you got the dipole moment, you have to apply in the formula of axial line and for the equatorial line to know about the equipotential surface of the system. So, V which is equal to 1 by 4 pi epsilon naught P cos theta by R square is the base formula for the system, right? So, for axial line, we know that it is a straight line, it is on the axis, so that theta which is equal to 0 degree, cos theta which is equal to cos 0 is 1. So, that we will get the value of cos 0 1, then V is inversely proportional to R square. Then we got the equipotential surfaces for the axial line are spherical. Got it? The second thing we have to take it for the equatorial line, theta which is equal to 90 degree. So, to know about very clarified things about the axial line theta which is equal to 0 degree and the equatorial line theta which is equal to 90 degree and all, we have explained in the previous sessions about these base formula. From that you can get it. You can check the base formula oriented that video, right? This for equatorial line theta which is equal to 90 degree. So that cos theta which is equal to 90 which means 0 it will come. Then here it will be the equipotential surface for the equatorial line is 0. Okay, there it is a spherical one. And the second question is, what is the direction of the electric dipole at every point on the surface? This will give, and also you can recollect the knowledge of equipotential surface properties. So, one of the property of the equipotential surface, as we know that, the direction of the electric field at every point on equipotential surface is normal to the proper surface. Got it, children? Yes. Problem 2. A spherical conductor of radius 12 centimeter has a charge of 1.6 into 10 power minus 7 coulomb is distributed uniformly on its surface. So, what is the electric field? A. Inside the sphere. B. Just outside the sphere. The question C. At a point 18 centimeter from the center of the sphere. As we know that very well, inside the conductor, the electric field is 0. Because outside the surface, the electric field will be there. Inside the surface, it is a closed one. Charge will be 0. So, the Q value is 0. Automatically, the electric field is 0. Right. The question B, is just outside the sphere. By applying the formula, we will get E, which is equal to 1 by 4 pi epsilon naught Q by R square. Here the R value, the radius they have given 12 centimeter, and the Q value they have given, that is 1.6 into 10 power minus 7. All the value we can apply, we will get the answer. We know that 1 by 4 pi epsilon naught value, which is equal to what? 9 into 10 power 9. 9 into 10 power 9 into 1.6 into 10 power minus 7 whole divided by this R square value they have given 12 centimeters, so 0.12 square. After simplified this, you will get the value of the 10 power 5 Newton per coulomb. You have to simplify, that is the mathematical work, you can do it. And for the C, part C, you will get, they have given at a point of 18 centimeter from the center of the sphere. The formula I can write E, which is equal to 1 by 4 pi epsilon naught Q by, you can write instead of that, they have given the value, so R square, that is equal to the same way, we can write 9 into 10 power 9 into the Q value is 1.6 into 10 power minus 7 whole divided by 0.18 whole square. After you simplify this value, you will get 4.44 into 10 power 4 Newton per coulomb. So this simplification work you can done it right. Problem 3. A proton is moved in a uniform electric field of 1.7 into 10 power minus 4 Newton per coulomb between 2 points A and B separated by a distance of 0.1 meter. The questions are, what are the potential difference between the 2 points and how much work is done in the above process, right? So the both questions, when you look at that, both are interlinked. If you got the value for the what is the potential difference between the 2 points, you will get the value for the what is the work done for the above process, right? So first question for that, what is the potential differences between the 2 points? The formula which is V, which is equal to E into D. So this is the formula for the first question, and what they have given, the given value we can write. Now they have given the electric field E, which is equal to 1.7 into 10 power minus 4 Newton per coulomb, and they have given the distance between the D value, which is equal to 0.1 meter, and you must know the value of the proton which is moved. That is nothing but what? That is the value of charge. So the value of charge is Q, protons are positively charged. So that 1.6 into 10 power minus 19 coulomb is the value for the proton, right? So by applying that E and the D value, we will get the potential difference between the 2 points, 1.7 into 10 power minus 4 into 0.1. So you will get the V value, which is equal to 1.7 into 10 power minus 5. Okay, volt. The SI unit, that is volt, you have to write it. Right. So the second question they have asked, how much work is done in the above process? Here you have to write W, work done, which is equal to what is the formula? Yes, V into Q, right? Or you can write, we have taken the Q value, which is small letter, you can take it Q. Okay, both you can take it, right? So W, which is equal to V into Q, by applying the value, we got the V value here in the above equation, 1.7 into 10 power minus 5 into the Q value is what? The proton value. Yes, 1.6 into 10 power minus 19. Got it? So by simplifying this, you will get 2.72 into 10 power minus 24 joule. That is the work done by the value. Problem 4. two point charges Q1 which is equal to 10 into 10 power minus 8 coulomb and Q2 which is equal to minus 2 into 10 power minus 8 coulomb are separated by a distance of 60 centimeter in air. The questions are: find at what distance from the first charge Q1 would the electric potential be 0, and also calculate the electrostatic potential energy of the system. So the first step, always we have to take the given values. So Q1 they have given 10 into 10 power minus 8 coulomb and Q2 which is equal to minus 2 into 10 power minus 8 coulomb, and it is separated at the distance of 60 centimeter. So they have given R which is equal to 60 into 10 power minus 2 meter. The question is: find the distance between the first charge Q1 would the electric potential be 0. With the help of, they have given the question, we have written and drawn the two charges which is separated at the distance of 60 centimeter. The Q1 from the center of that, this value we have taken X, right? And this is R minus X. Q2 which is R minus X from the O, right? Now, we know that VOA, that is the potential at OA, which is equal to potential at OB. So that the formula which is equal to KQ1 by X plus KQ2 by R minus X, which is equal to what they have given? Be 0. By applying this value, we will get the value of charge, what is the distance, right? So K, that is the value of KQ1 by X into KQ2 by R minus X value we can write. So here the KQ1 is 10 power minus 7. So we can write by X, which plus we can take 2 into 10 power minus 8 whole divided by R minus X. We have to take 0. By simplifying this, we will get 10 whole divided by X, which is equal to 2 by R minus X. So we will simplify it. Then we will get the value of we can cross multiply 10 into R minus X, which is equal to 2X. So we will get 10R, which is equal to 12X, or else we can write the value X, which is equal to 10 by 12 into R. As we know that the R value, which is equal to 60 into 10 power minus 2 meter. So by applying this R value, because R which is equal to what? 60 centimeter they have given. So X which is equal to, by applying 60 here, you will get 50 centimeter, or you can write X which is equal to 0.5 meter. Got it? So this is the X value, right? Or you can take 50 centimeter or else X which is equal to 0.5 meter. So the second part of fourth question is what? Also calculate the electrostatic potential energy of the system. The electrostatic potential energy of a system, we can write En, which is equal to K Q1 Q2 by R, which is the formula for that, right? So by applying that directly, the values of Q1, Q2 and R we will get, so which is equal to K value, that 9 into 10 power 9 minus of, you have to take it, and the Q1 value into 10 power minus 7 into 2 into 10 power minus 8 whole divided by the R value, which is equal to what? 60 into 10 power minus 2. Okay. By simplifying this, you will get the value of minus 3 into 10 power minus 5 joule. Got it? So this is the electrostatic energy of a system. Yes, problem 5. A parallel plate capacitor with air between the plates has a capacitance of 8 picofarad. What will be the capacitance if the distance between the plates is reduced by half. We are reduced by half. And the space between them filled with the substance of dielectric constant is what? 6 they have given. So first we can write the given value C, which is equal to what they have given? 8 picofarad, or we can write 8 into 10 power minus 12 farad. This is the value for that in given. As we know that very well, the C naught formula, C naught which is equal to epsilon naught A by D. So this is the formula for that. Now they have given in the question a clue is the distance, the capacitance of the distance between the plates is reduced by half. So if suppose we have taken the new D dash which is equal to D by 2, then the dielectric constant K which is equal to 6. By applying this value, we will get C, the new C which is equal to, because C which is directly proportional to C naught, or C which is equal to K C naught. So this is, we know that from the theoretical part, we got all the things, that derivations. So C which is equal to, we will get that 12 epsilon naught A by D. So from comparing these two, you may get C which is equal to 12 C naught. Is it right? So C which is equal to what we got? 12 C naught. So applying the value we will get right. So the value of C, they have given C value which is equal to 12 into 8 into 10 power minus 12. So we got 96 into 10 power minus 12, or we can get C value which is equal to 96 picofarad. So this is the capacitance of the value, the parallel plate capacitor. This got the value of C which is equal to 96 picofarad. Problem 6. A 12 picofarad capacitor is connected to a 50 volt battery. So how much electrostatic energy which is stored? The electrostatic energy, direct formula relation we can use, that is En which is equal to half CV square. So this is the formula, direct formula, we can use it right from the derivative part. So you can apply the values of half into 12 into 10 power minus 12. That is the value they have given, picofarad. So that is equal to what it will come, the value is, and you can write the V square value 50 square. So by simplifying this, you will get the energy value which is equal to 1.5 into 10 power minus 8 joule. Got it? So this is the direct sum, and this numerical you can take it, the value or the formula from the direct derivation, electrostatic energy which is stored in the capacitor, En which is equal to 1.5 to 10 power minus 8 joule. So problem 7, 3 capacitors each of capacitance 9 picofarad are connected in series. The questions are, what is the total capacitance of the combination, and what is the potential difference across each capacitor 1 farad, and the combination is connected to a 120 volt supply. See, the diagram it maybe comes like it is in series, so that, so C1 or C, the 3 Gs which are connected in series, right? So the across the battery which is what? 120 volt. They have given C which is equal to what is the value? 9 picofarad. We need to know, the question A is what is the total capacitance of the combination? Right. So 1 by CT, the combination of, which is equal to 1 by C plus 1 by C. We have to take another 1 by C. So the value of C which is equal to 1 by 9 plus 1 by 9 plus 1 by 9 again. So that by simplifying this, you will get the CT value which is equal to 3 picofarad. Okay. So this is the value for the capacitance of the combination, right? And the question B is, what is the potential difference across each capacitor if the combination is connected in 120 volt supply? That is the second question. Okay. So the formula is for that potential is Vt which is equal to V1 plus V2 plus V3. Here we have taken that V which is nothing but what? 120 volts. So V1 which is equal to V2 which is equal to V3. So that 3V which is equal to Vt will come. The Vt value which is equal to what? 3V which is equal to 120 volt they have given. So they have given 120 volt battery. So V which is equal to 40 volt. So this is the potential difference across each capacitance. The combination which is connected to the 120 volt means so 40 volt, right? Problem 8. Obtain the equivalent capacitance of network in the diagram. See, for 300 volt supply, determine the charge and the voltage which is across each capacitor you have to calculate. So the diagram they have given as two with series and one is with the parallel. The 4 capacitance they have given. We can redraw this diagram as we can. So the capacitance C1 which that C2 and C3 which is connected and the C4 which is connected with parallel with this. So this two if you have calculated with this combination of series of C4 we can calculate, right? C2 and C3 and the 300 volt supply is connected here, right? So when we redraw it for your arrangements, it will be easy. So values and all the same, right? Now, from the diagram, you may understand that first we can achieve this in the series way. C2 and C3 or series. So that we have taken the equivalent value C23. For the C23, we are going to calculate it. So C2, C3 by C2 plus C3. This is the base formula. We got it from the derivative part of the capacitance in series and capacitance in parallel. Right. Now we have taken for the C2, C3 is in series. So that C23 which is equal to C2, C3 by C2 plus C3. We apply the value of C2 and C3 200, 200. Whole divided by 200 plus 200. We will get the value of 100 picofarad. Right. Now the C23 which is parallel with C1. Now how it will be get modified? You may get modified of the C23 will be like this. Is it right? C2, C3 will be changed as C23. Now C1 and C23 is a parallel one. We can approach this parallel. We can resolve this. So you will get, you may name it like C123. So that C1 plus C23. So this is the formula of the parallel of capacitance, right? So the capacitor which is in parallel, you will get directly Cp which is equal to C1 plus C2 plus C3 and till Cn we can take it. So here C1 plus C23. So we got directly the value of 200 picofarad. Now you can take the C123 in series. This both will be together like C123 like this. It will be C123 and this is C4. So this will be like this now. Okay. So finally we simplify 300 volt. So now directly you can use the series. That formula C4 which is equal to C1234 we have given. And C123 into C4 whole divided by C123 plus C4. So finally we got 200 by 3 picofarad. So we resolved for the individual values and finally the one single capacitor we got at C1234 value is what? 200 by 3 picofarad. Now the question is the charge and the voltage across it. First we can see the charge. The total charge Q we got to 200 by 3 into that 300 the capacitor's value. So 2 into 10 power 4 we got it. So the charge value which is nothing but C4. For the C4 we can take Q4. So that 2 into 10 power 4 picocoulomb. So you have to calculate for the charge for the other values also. So C1 we have taken C1 which is equal to what? C23, right? So we can take the Q which is we can divide that equally on the C1 and C23. So we will get Q1 which is equal to Q by 2. So that 10 power 4 picocoulomb we will get it. So Q2 which is equal to Q3 also because C23 which is equivalent of Q2 and Q3. That is also we have taken Q by 2 which is equal to 10 power 4 picocoulomb, right? So we are going to now calculate the voltages. So now we got the value of charges for Q1 and Q2, Q3 also 10 power 4 and Q4 before that also we got it. So with the help of that Q1, this formula, base formula, that is for the voltage is V1 which is equal to Q1 by C1. By applying the directly Q1 and C1 value what we have already calculated, we'll get the voltage value, right? Voltage across each capacitor we will get. So V1 for the first capacitor, the voltage 1 which is equal to Q1 by C1. Q1 value is what? 10 power 4 picocoulomb whole divided by C1 value is 100 picofarad. So that we will get 100 volt, and V2 also in that same way we apply, we will get the value of 50 volt. So V1 which is equal to 100 volts and V2 which is equal to 50 volt we got it. In the same way for the V3 and V4 also we have calculated. V3 formula is Q3 by C3. So we got and simplified the value as usual as we know that. See here the charge which is divided by 2 that halved. Then usually here also it will come like V2 and V3 which is equal to 50 volt and V4 value Q4 by C4. By applying that Q4 value is what? 2 into 10 power 4 picocoulomb whole divided by the C4 value is 100 picofarad. So we got the V4 which is equal to 200 volts. Yes students. So far we have learned through this session about electric potential and capacitance of various problems we achieved. Hope you understood the session well. Thank you students.